I'm Bob Graybill, President and CEO of Nimbis Services, and I want to thank Jim Wetzel and the panel here for setting a very high bar, what the platform is going to look like and do.
Your implementation.
That's right, details. But the exciting thing about what we're doing, we've actually dove into and building the test bed. We're making good progress, and I'll tell you some about that. And the other thing is, it's not just Jim Davis and Nimbis Services that is building this platform. It's really a contribution from the overall community that's going to make this platform a success. And so that's what's so important about this. Not only the users, but also automation vendors are part of this solution. So I'd like to talk a little bit about some of the platform specifications. I'm going to repeat a few of the view graphs that Jim Wetzel presented, but I'll talk from a more requirements perspective. So this is one that Jim presented here. And one of the things I want to highlight here that requirements that flows down is dynamic orchestration of your workflow, of the entire process and responsiveness. That is going back to real time again, in other words. That's a very important attribute. Another one is provenance. Maintaining the provenance of your data entire way through your supply chain is very important from a regulatory perspective, from a process improvement perspective, and thirdly, from a security perspective. Just like when your credit card is monitored for any unusual behavior, we want to monitor this entire flow for any unusual behavior by any unusual people having access to it, or unusual process variations, or a number of things you can look for. So we talked about security. Security, it can really be built in as part of your process. So it's really a systems-to-systems type of approach. And so we can use some of the different attributes we need for provenance as part of addressing the security issue that was brought up earlier in one of the other panels. The other thing to keep in mind, and this was alluded to by the Internet of Things panel, is that we're talking about a rather complex system. We can talk about if you want to go to extreme of the product design of the product to the actual process development, manufacturing, and then actual distribution, qualification, and so forth. But as you look down through the hierarchy there, you can be operating at the macro level, which is number of control loops and time of days. You're all talking about in a meso layer of tighter control loops and more loops. And then you go down at the factory floor level, which is very tightly controlled control loops. And depending upon where you are in the supply chain, smart manufacturing needs to probe down into different types of layers. If you're working with a larger manufacturer, you're probably going to be talking at a much higher level because they have very sophisticated automation platforms already in their plant. But if you're talking to a small manufacturer or a grain elevator, the best you may get is a fax machine. So, I mean, it will vary, in other words, across here. So the smart manufacturing platform has to plug into these different points here. There's also a very large existing infrastructure of automation vendors that are out there. And this has grown over the years from MES, CPM, and MOM. And smart manufacturing really encompasses all of that. It really complements, not replaces these other systems, but plugs into where it's appropriate. And you see a little bit of elliptical white space down at the bottom. That may be the grain elevator, where they don't have any of this, in other words. So we have to plug into it. So that's just something to keep in mind from a platform perspective. This is a slide that Jim Wetzel also highlighted here, but I want to highlight the fact on the right-hand side where it says collective wisdom, smart. That's where we intersect with the Internet of Things. We can plug into the data, the sensors that's being provided and integrated through that, in other words. And so we're operating at a level above that, in other words, from a smart manufacturing perspective. This is another slide that Jim presented, but one other attribute I want to highlight here is not only do we need to provide a marketplace that can be used across this entire supply chain, but there are cases where manufacturers want to have that smart manufacturing platform within their plant for security reasons or whatever. So one of the requirements for the platform is that it is open and it has to be able to be hosted within a plant's system, which means it has to support and run on different hardware platforms. So therefore, you need an open infrastructure in order to support that. So we envision this being a smart manufacturing platform or service that's part of SMLC, but also for the members, they could take that platform and take portions of it and host it within their plant. So that's another requirement. Now I'll skip over that one. And that gets down a lot of gory detail. So what I'd like to talk about is the DOE project that was mentioned by Denise. We are in the beginning of year 2 of that project, or a 3-year project. And it's quite exciting because we're working with Praxair and General Dynamics. And I'm going to give you some status on the Praxair one and demonstration that we did recently for the SMLC board. So here you see the functional architecture of this test bed, to validate the principles and approach for the SMLC platform. You'll see there's 2 threads there. You see the bottom thread is the Praxair thread, and then the one next level up is the General Dynamics thread. And so from a data flow perspective, you can see on the left-hand side, the first box there is all the existing infrastructure in the plant. The GES storing for Praxair, OPC server, sensors, connects, and other smart manufacturing sensors. For the DOE project, both Praxair and Dynamics had to add additional sensors to the plant in order to instrument it. And one of the things come out of this test bed is how many instruments you need, what type of data you need, and so forth. So it's sort of a learning process. It's, how many sensors do you really need in order to get the answers you want? So then the data the question is, how do you get the data in the cloud? The approach we've taken is to have a separate server, gateway, if you wish, to the outside world. And it can be called a concentrator, or it can be called a secure server, but in each case, it only allows the data that Praxair or General Dynamics wants to push in the cloud to go through there. So it's sort of isolated from the plant and also isolated from the cloud. So that's a gateway to manage it. And then there's a lot of existing interfaces out there that already exist into Historian. So we're leveraging that kind of approach. And for this test bed, we happen to use the Emerson OSI Pi interface. So we actually have a lightweight Historian in the cloud to collect the data, which may be image data or point data, instrument data from the plants. From there, it flows, it's made available then to a workflow engine. And in this case here, we're using Kepler with open source workflow, but we can support many other either proprietary or open source workflows in place of that. And then it goes up to visualization and up to the user. From a user perspective, the user will log in, let's say, from Praxair. They'll get access to their dashboard, which is populated with their applications they've selected from the marketplace. They can then massage and adjust and analyze the data that's coming through from their plant. So that's the overall flow of what we're doing under the DOE test bed. One of the things interesting things that came out of the DOE test bed is how do you integrate the modelers into this overall environment? We've talked a lot about the actual plant engineers and how they may use this platform. But in the first year, a lot of the model development was done on, modelers used their own workstations. But they really need access to real-time data. And so what we're migrating to under the DOE project is developing you can see that middle real-time model and Kepler workflow development portal for modelers. That is going to be an environment that is our container environment, in essence, that's spun up for modelers to develop and get access to data from Praxair and General Dynamics. In parallel with that, there is a container for Praxair. And if I go back one slide here, Everything, you can't quite see it. Everything on the blue here, you can't quite see. Everything to the right of the SM Connect, to the right-hand side there. That is all in the cloud, and that's in a container. And so if I go here, you see the Praxair and General Dynamics container. That's what's in that container, that functionality. And you can see the data being fed into that from the Praxair or General Dynamics plant. One of the real benefits of this is the modelers and the Praxair and General Dynamics have access to not only their own proprietary applications and apps and data within the marketplace, but they can also share applications across there. And that's also a place that we want to host a lot of vendors' software applications there to be used. And so that's where we see a great advantage for small and medium-sized companies to host their applications there and also get access to data to develop better software. But also support major automation vendors' software in our workflows in that model also. So the tightly integration of the workflow with the access for modeling development to the real-time data and with the actual testbed containers is very powerful. So I'm going to give you a use case here and where Bob is a Praxair engineer and he notices something that is unusual happening, and so he realized he's going to have to develop some new models. He's going to have to model this and predict what's going on. So he has to go through this type of use case. So he wants to evaluate new operating modes. Like I mentioned before, he wants to use new modeling techniques. So he pulls from the application marketplace different software packages. He puts them on his desktop. He collects the data. He runs the workflows, and eventually when he's happy, he's going to put them back into the library. But in the meantime, he's going to then log into the Praxair testbed, access his dashboard, run it, collect data, and so forth, and iterate on that until he's happy with that. So that's sort of overall use case that we have demonstrated about 2 weeks ago. And these were some of the 4 different demonstrations that were done. One was collecting real-time data from Praxair, and with it ending up in a platform cloud-hosted OSI historian. There was model development involved in that. There was a resulting kept flow workflow that came out of the model development. And then the actual access of the portal, the marketplace, and running of Kepler and viewing of that. One of the things that came out of that that's very important is that these demonstrations were actually were done in one form or another on 3 different platforms, all using OpenStack. One was Cisco, one was, I don't know what Rackspace uses, and another one was on UCLA's academic OpenStack platform. So we actually demonstrated the portability of this platform. In this case here, data was collected from Praxair. You want to say anything about this data? Or?
No, I don't.
No. Okay. Okay. It's sensitive. But go ahead.
So in short, the process, is a steam methane reformer, which is this big 40-foot cube of a furnace, right? You look inside and it's what hell would look like, right? When you look inside, right? A bunch of combustion burners and so forth. So we have no insight traditionally into what's going on inside the furnace. We measure a couple things in the outlet, and as part of this project, we put additional instrumentation inside the furnace as well as some imaging tools to help us better understand what's going on in the furnace, and then we can apply, obviously, analytics to it and so forth.
So now we have the data, and now the modelers will have to go and fine-tune their techniques using that data. And so that's the sort of stage we're at. And this just shows and demonstrates some of the capability you get out of OSI software historian. And the next two slides are really just highlight some of the thought process the modelers go through in analyzing the problem. And this just highlights again some of the model development workflow activity of getting access to the data, and then validating the models, and they're going to maintain the model over the life of the product. And then that model development is then implemented in a workflow. And this happens to be a Kepler workflow, and so this is the workflow is actually executed on the platform then. And you can go in there and change parameters and adjust and so forth. And it's really a mashup of different software packages. In this case here, it's a mashup of MATLAB and ANSYS CFD code. And as I mentioned before, provenance is paramount. So this is one of the things we want to demonstrate very on, is ability to maintain that provenance across the system. And so that was demonstrated within a Kepler type of environment. And then a couple slides on the marketplace. You go into your catalog on the left-hand slide, and you select, right now in the Praxair case, you have one catalog item. The very first workflow engine for that. You select that, and then it ends up in your dashboard. You then go and actually start it, as you can see here. And then you can see it barely in yellow where it's spinning up the virtual machine. And then you're executing it. And here again, just a couple of screenshots of different workflows and how you can interact with that and visualization on that. So that's what was demonstrated. The goal for this year, by the end of this year, November timeframe, for the DOE project, is to have data flowing completely for both General Dynamics and Praxair from the left-hand side the whole way through here up to a point where you are starting to be able to collect some metrics. So that's where we're at. So we're ahead with Praxair where we actually have data flowing through that, but they have to fine-tune the model some more and complete the interface for the Praxair engineers to actually use it. Do you want to say something?
Sure. I mean, so simplistically, right, going back to what I talked about earlier, the benefit here for us is this demonstration of being able to pull a bunch of data out of our system at a very low cost, kind of throw it up to the cloud, and let a well-defined set of collaborators take a run at it and do stuff with that information, right? So that's really what we're trying to demonstrate here.
Mm-hmm. And that reminds me of one thing I should highlight back here. Gotta hurry. Is that each of these test beds or these containers are isolated. So we are using role-based access so that only those folks, the Praxair engineers or General Dynamics, can actually get access to those containers. And also within the library, the IP is protected through an object-based oriented type database, and that's all role-based access controlled also. So entire through here, this cloud, you can very narrowly define what is visible by the user and by the company. So it allows folks outside of Praxair to get access to the data that they want to use for modeling purposes. And that's important, in other words, for collaboration purposes.
And I think what's important too is that one of the goals we have is to demonstrate that the use of the platform and this configuration cuts down the time and cost of model development. And we are going to, now that we've done the first run at it, we're going to start keeping track of if the platform wasn't there, what would it take, what would be the time and cost of the model development, and then with the platform there, and then replication. If you're going to do it at on another furnace, how much more does it cut the time and the cost of model development? So it's not only the influence on the performance optimizing the furnace itself, but in addition to that, it's how more cost effective it is to do what you need to do to get there in the first place, which is modeling and simulation. The other thing I want to say very quickly is that we are very much use case driven in our test beds, and one of the drivers besides what we just said on modeling was that for Praxair, it was the first time of connecting a high fidelity model in the cloud to a reduced order model operating at the plant level with the plant control systems to optimize the furnace. That seemed, at least for the chemical industry and the processing industries, was a holy grail that would be important for the platform to be able to address.
Yeah, I'm not sure I agree with that, but we could talk about it more afterwards. I think, if you think about the process of doing this model, right, as you say, you're going to collect some data, there's going to be a box to validate, if you will, in the workflow. There's a box to validate that those measurements are any good or not. And then from there's the data transfer piece, there's a validation piece, then there's the modeling piece in the middle, and then the back end, right, there's sort of a similar kind of process in visualizing it and so forth. So, when we view it as a bunch of those discrete steps, our view of it is most of those things and sort of calculations or algorithms within them should stay the same and shouldn't change over time. There's a core piece of this model in the middle, right, that has to be, that may have to be calibrated or recalibrated once in a while, but again, that's, so I guess some of those issues will exist, right? There's always that issue in the process industries of keeping the model fidelity up to a certain level. But from our perspective, it's valuable still. I mentioned earlier having to deploy something to 200 facilities. I need an easy way to do that from an infrastructure standpoint. Mm-hmm. Yeah. Well, the calculation. Yeah. I mean, my view of that, the calculation strategy of how to figure that out, the problem doesn't go away. You're absolutely right? The calculation strategy around how to evaluate that from plant to plant should be the same. And so then it's a question of, like I say, how do I deploy that strategy to a wide global base of assets? So that's our view of it.